Another key thing from grade 11 that's really going to help us with limits is rationalizing. In grade 11, you had to rationalize the denominator. Now for limits, sometimes it's going to make sense for us to rationalize a numerator. So that's kind of different. In grade 11, the whole idea of rationalizing a denominator, if I had you in grade 11, I might have explained that the reason for that at one time before calculators, it was a lot easier to divide by a whole number or by a fraction or any number, but if you were dividing by an irrational number, like a square root, that took a long time to do by hand. We don't have to worry about that anymore because we have calculators. So if you wanted to divide by the square root of 2, you can just type that into your calculator, no problem. But the original idea of rationalizing the denominator came from that because it made your calculations when you were doing them by hand go a little bit faster. But we see that this idea of rationalizing the denominator, this idea of multiplying by the conjugate, so here's a definition that you may or may not remember. The conjugate is just the same binomial with a different sign in the middle, helps us get rid of a square root. And it's using the idea of difference of squares, because if you have two conjugates multiplied together, you get a difference of squares. And the nice thing about a difference of squares is you square the first one and you square the second one. So if there were any square roots, they're going to be gone. They're going to go away because you've just squared both of them. So here's our first example. We've got square root of x plus 3 minus 2 on the bottom, and we want to rationalize that denominator. So we write the same thing, but the conjugate, because that will create a difference of squares on the bottom. What we'll end up getting on the top, we'd have to distribute, so we get 2 square root of x plus 3 plus 4. On the bottom, because this makes a difference of squares, we're going to get the first one squared. When that gets squared, the square root would go away. We just have x plus 3 minus the second one squared. And looking at this, we have some simplifying that we could do on the bottom. And this just becomes x minus 1. So by multiplying by the conjugate, we're able to rationalize the denominator. And the reason it's called rationalizing the denominator is because we no longer have a square root on the bottom. Now, when you did this back in grade 11, it was always with numbers that you had on the bottom. So now this is the first time that we're doing it with variables inside square roots. There's another example right underneath this. I want you to try that one on your own. I'll give you a little bit of a head start, and then I'll put the answer up in a second. So a common mistake that students will make is they'll forget to multiply by the conjugate. They might multiply by the same thing. So make sure that here we see the minus sign, because that's the conjugate of the plus sign there. Then once it's simplified, this one's kind of nice. The x's go away altogether on the bottom. And you could either leave it like this, or you could factor out the 5. Rationalizing the numerator is the same idea, except now you're looking at the numerator and saying, oh, there's a square root in my numerator. How would I get rid of that? I would multiply by the conjugate. So here it would be square root of x plus 4 on the top and square root of x plus 4 on the bottom. On the top, it'll make a difference of squares. So the shortcut is you square the first one, which will just be x. Square the last one will be 16. It'll just be x minus 16 in the end. And on the bottom, well, we could leave it factored like this, but if we wanted to multiply it all out, you would get x times root x minus 16 root x plus 4x minus 64. Of course, now we have square roots on the bottom, which is what we're like used to not having. But there's going to be some situations where it's going to make sense to rationalize the numerator. And we'll see what that looks like later on. So again, here's another one for you to try. Put the answer up in a bit. So one thing I wanted to show you on this last one, now we multiplied out the bottom. Let's say we didn't do that right away. Let's say we multiplied out the top and got x minus 16. But we decided not to multiply out the bottom. Why might this be helpful? Yeah, we have two things that are exactly the same. So if we had simplified those, okay, that might make things nicer. And also with this, when you simplify this, sometimes people say, well, this all canceled out. I just have this left. But we have to be careful because that's in the denominator, right? So we have to write this as 1 over the square root of x plus 4. You could. You could write this in brackets. And it's going to be very helpful to use that later on when we do derivatives. Sometimes it's going to be nice, instead of writing something in the bottom of the fraction, to use our negative exponent law and pull it to the top. Yes? Oh, well, this part from here to here, or from here to here? So if we multiply out the tops, which we did last time, we got x minus 16, right? So that's where this x minus 16 is. And if I decided not to multiply the bottoms, then I'd still have this one. And I had x minus 16 to start with as well. And then those two are identical, so we could simplify them. And generally, when you have a rationalize the denominator, a question where it's going to make sense to rationalize the numerator, it's because something like this with the simplifying can happen. And that generally makes the question solvable when we get to limits. Yeah, so I kept it factored first to see, because once you get it to this, to undo that, like to recognize, oh, could I factor that, is not easy. This one could be factored by grouping, and then it would come out again, but it's not easy to see. Oh wait, let's see how you did on this one. No, this is not the one we're looking at. This one right there. The next one. This is the one. So we'll multiply by x root x plus 1 and x root x plus 1. When you multiply these two together, the x times x will be x squared. Root x times root x will be x. Together, that would be x cubed. Okay? What I have in the blue above there is just showing you that if you wanted to write x times square root of x as a single square root, it's equal to the square root of x cubed. And sure enough, later on when you get that, you get the square root of x cubed. Then, before you multiply out the bottom, again, just like last time, we're going to leave it factored this time, because maybe later on there'll be something that allows us to simplify this further. For this question in particular, if I multiply this out, I would get x cubed minus 1. And that x cubed minus 1 might trigger you to something we did earlier today, and you say, hey, that's a difference of cubes. I have a formula for that. I can factor that further. So if I factor that further, I'd pull out the x minus 1, and all of a sudden, again, it simplifies. And in the red off to the side is just a reminder of something you did in grade 12. When you could factor two things and they simplified like that, that would give you a hole in the graph. So this officially ended like a little section. And at the end of the section, again, I put this, need some practice on to try. Just to give you a feeling for how this textbook works, I'm going to give you some time to work on that right now. And I'll hand out textbooks to people that don't have them. So we will have time to work on some questions in class, so make sure you do bring your textbooks to class. If you don't have it today, maybe you can work with somebody.